Vector with capacity. Vector with capacity is used to pre-allocate memory for a vector when the final size is predictable. In this video, we'll see why we use vector with capacity can improve performance and when we should use it. So, what problem are we solving? So, let's look at this example where we create an empty vector and we're iterating over 0 to 1000 of records, and we are appending every element to that vector. So this code works perfectly fine, but internally every time the vector grows beyond its current capacity, Rust has to allocate a larger buffer, copy the existing elements, and free the old memory as well. This process happens multiple times as long as vector keeps growing. So how can we improve this? So now let's look at this example where nothing's much changed, but we have uh, vector with capacity where we have initially uh, upfrontly we have provided our capacity to that vector, like these many records are going to be in that vector. So by following vector with capacity, not only we are uh, providing the final size upfront, but as a result, memory is allocated only once. There are no reallocations and no unnecessary memory copies. The logic will be the same, but we have just removed extra work. So now let's look at the real world example. Let's comment this and let me uncomment this code. Uh, Sorry about that. In this example, we are created created an n with 10,000 numeric digit, and we have append that capacity to our vector initially, and we are iterating over that n time, and we are iterating over n time in our loop, and we are appending new element, and that new element will be some dynamic read number function. It could be anything, but for this tutorial we are just using this sum read function. So if you already know how many elements we are going to collect, reallocating the vector avoids repeated memory allocations and improves performance. So yeah, we can provide the capacity of a vector upfrontly to reduce memory reallocations and improve our loop iteration logic. So similarly, string also have with capacity upfrontly. By providing the length of string upfrontly, we can also reduce memory allocations in string as well. Why? Because strings are also uh, allocated in the heap just like vector, because strings are dynamic in Rust. So to prove this, why vector with capacity is better than vector without capacity, we have created performance analyzer benchmark, where in that file we have created two functions. First is uh, without vector with capacity, where we have initialized our vector without using vector with capacity, and the second function where we have initialized our vector with 10,000 of records, and we are iterating both of them uh, n times, which is 10,000. And let's see which function performs well. So we run this our cargo benchmark, and let's see what happens. Okay, it's taking its time. So let's wait for a few seconds. I guess there's an issue in that. Let's again run this benchmark. So let's wait again. Okay, we have run our cargo benchmark to see performance, and let's see which runs faster. So let's wait for a few seconds. So, uh, vector, yeah. So as we can see, vector with capacity took only 10.795 millisecond, whereas vector without capacity function took around 17 millisecond. So as we can see that uh, using vector with capacity upfrontly by providing the uh, capacity of a vector, uh, we improve uh, we reduce fewer allocations and reduce less memory copying. So when should we use vector with capacity? Use it when you know the size beforehand, you are inside a loop, the code runs frequently, you are building data step by step. So final takeaway is vector with capacity doesn't change your algorithm. It simply prevents rush from doing unnecessary work. If you know the size of vector, just tell it to the rest. So yeah, that's it for this video. Thank you.